Welcome, everyone. This is Libby Mucciaroni, Associate Director of Education, Technology, and Member Engagement at the Organic Trade Association. I'm pleased to welcome you to our webinar, Managing Soil Amendments for Food Safety and Soil Health. A couple of housekeeping items before we start the presentations today. This webinar is being recorded. Our panelists have provided a number of helpful links as companions throughout the presentation. We will share them through the chat box throughout the presentation and after in the email. In the next 2 business days, all registrants will receive a follow-up email, including the PDF slides from today's presentation, all of those helpful links that we'll share throughout the presentation, and a registration link to view today's recording on demand. During registration, we ask that you let our presenters know any questions that you had on today's topic. With over 300 registrants, we're thankful to have such a diverse and engaged audience. Your questions have been taken into account for the panelists' presentations and in preparation for our Q&A session today. For any questions or comments that you may have during the discussion, please share them with us in the questions pane on the platform. Our presenters will respond to your questions as time permits during the Q&A discussion. For any questions not addressed today, we will follow up with you within the next week, or if it pertains to our session next week. And finally, if you happen to have any technical issues during the presentation today, please notify us through the questions pane or via email. The Organic Center is a nonprofit research and education organization based out of Washington, D.C. They work to conduct and convene credible evidence-based science on the environmental and health effects of organic food and farming, and to communicate the findings to the public. The Organic Center's work is supported by companies and individuals who desire a sustainable and secure food system that promotes the health of humans and the environment. The Organic Trade Association is a membership-based organization for the organic industry. We ensure that all parts of the organic value chain have a strong voice in government and in our communities. We bring farmers, processors, distributors, retailers, and others together to promote and protect the growing organic sector. OTA represents its members to government on sector needs, market development and promotion, and strong organic standards and regulations. Members also receive the latest information and quick answers on organic regulations and standards, both in the United States and around the world. Today's webinar is a session 1 of a 2-part series on soil amendments. If you haven't yet, please consider joining today's panelists with us next week on Friday, July 23rd at noon Eastern, 9 a.m. Pacific for science-based composting practices. And the link was shared previously when you first joined, and we'd love to have you join us if you haven't registered yet. Today's webinar is hosted by Dr. Jessica Shade, Director of Science Programs at the Organic Center. You can learn more about Jessica and the Organic Center at the link I'll share momentarily in the chat. And with that, I will hand the reins over to Jessica.
All right, thank you so much, Libby. Hi, everyone, and thanks for joining us to talk about managing soil amendments and food safety and soil health. We've been working with this team for over 5 years, starting with the USDA-funded planning grant to assess the landscape of organic use of manure and other animal-based soil amendments, and then building on that with a multi-million-dollar field project to directly analyze food safety in the context of raw manure use. So I'll let Alda talk more about the full research project, but to give some context, we reached out to her and the rest of the team after the FDA proposed revisions to the Food Safety Modernization Act about 8 years ago, and that their proposal included changes to the required interval that untreated manure could be applied and crops harvested, suggesting a 9-month minimum interval requirement, which directly contradicted the National Organic Program regulations for application of raw manure. And that ruling was not adopted because FDA decided that further research was needed, mostly thanks to comments from the OTA and many of the people on this webinar. And our research aimed to make sure that organic systems were included in the collection of that additional data, so that all of the data wasn't just collected on conventional systems. So today we'll get some background on the full research project from Alda. but we'll mostly be focusing on the benefits and risk reduction practices when using manure, compost, and other animal-based soil amendments that are often used on organic farms. So specifically, Betsy and Donna from the Produce Safety Alliance at Cornell University are going to be talking about how the use of animal-based soil amendments can improve soil health, and information about how growers can minimize the risks of using untreated soil amendments through proper application, storage, handling, and record keeping practices. And just a reminder, Libby mentioned this, but as a reminder to everyone, this is a two-part series. So we really encourage you to join us on Friday, July 23rd for our second webinar in the series, which will focus on science-based composting practices that growers can use to minimize microbial food safety risks while still reaping the soil health and production benefits from the use of animal-based soil amendments. So I'm going to introduce our speakers, and then I'm going to hand it over to Alda to start us off. So Alda Pierce is an Associate Extension Specialist in Urban Agriculture and Food Safety in the School of Veterinary Medicine at the University of California. Her research and outreach focuses on pre-harvest food safety and mitigation strategies for reducing food safety risks in the farm environment of small-scale, organic, and diversified production systems. Donna Clements has served as the Produce Safety Alliance Southwest Regional Extension Associate since 2015. She's based in Riverside, California, and she leads training courses on the FSMA produce safety rule. She provides technical assistance to growers and produce safety educators, and she develops educational food safety resources. Donna's going to be doing most of the Produce Safety Alliance presentation, but we also have Betsy Bin with us, who's going to be joining for the Q&A session. And Betsy is a senior extension associate at the Department of Food Science at Cornell University. She's currently the director of the Produce Safety Alliance and the National Good Agricultural Practices Program. She has over 22 years experience in extension, and her program aims to reduce microbial risks to fresh fruit and vegetables by developing education materials through collaborations with growers, farm workers, produce industry personnel, students, teachers, and consumers. So Alda, I'm going to hand it over to you.
Hi, everyone, and thank you, Jessica, for the background and an introduction. So as Jessica mentioned, today I'm going to present some of the findings of a multi-institution collaboration. I've been working with the Organic Center and other collaborators for over 5 years. And I'll just give an overview of that research. And it's a multi-regional risk assessment of farm of manure use on farm. Next slide, please. Thank you. So we know that certified organic producers use biological soil amendments of animal origin, manure, and compost to improve soil fertility and quality. Next slide, please. And a few years ago, we were very interested to know what are the practices that certified organic producers, specific for produce production, are having across the state. So we did this needs assessment, a survey. It was a multi-regional survey with listening sessions to understand what were the practice and the needs of in terms of research and outreach. So a majority of the participants, they report it was very important to use on biological soil amendments of animal origin because of soil health, nutrient management, soil tilt, cost and animal waste management. And this was over 85% of participants. They mentioned the reasons why they're using soil amendments of animal origin. Although we saw regional difference between West and Midwest in terms of what type of soil amendments are using, if it was untreated or raw manure and compost. And in terms of sources, most of the sources were poultry, cattle, and horses as a source of manure. So this is a very extensive survey, but that's kind of main findings. There was regional difference. a difference in terms of practice for produce itself. And we know, next slide, please. So we know that all manure may carry human pathogens as E. coli on 5.7, Salmonella, Campylobacter, and among others. And the untreated biological soil amendments as raw manure or aged manure are higher risk since they have not treated to reduce pathogens when used for production of fresh produce that normally we eat raw. Next slide, please. So the prevention of microbial contamination is being based on time criteria between application and harvest. Next slide, please. And national certified organic producers, they follow the standards of NERP, so they will wait between 90 days and 120 days between the application of untreated manure and harvesting. Next slide, please. What we know in terms of what factors affect the survival of the pathogens and understanding is this time interval, 19 and 120 days, is that time interval enough to reduction of those pathogens? There are many factors actually that affect the survival of those pathogens in manure, the source itself, the pathogen itself, the source if it's from dairy, husbandry practice, characteristics of the manure and the bedding of the soil, and then also agriculture practice. So there is many multi-factor factors affecting the potential survival and persistence of foodborne pathogens in soil. Next slide, please. So those factors, they don't work by itself. They are all interrelated and they have a different function. So in this diagram, we have in measured groups as the characteristics of the soil, the land use and agronomic the practice, irrigation water, manure itself, and abiotic factors as weather, climate, and so on. So all of them, they interplay a role, and we're very interested to know what's the major factors affecting survival in organic systems, and that's what this project about. Next slide, please. So we conducted a multi-regional project over 2 years on farms. So it was a collaborative work with commercial farms in different regions here in California, Minnesota, Maryland, and Maine. They were all certified farms, and they are using some type of untreated manure. And we survey these farms, follow up these farms over to growing season, so to be able to see spatial and geographic difference between the practice and potential effect on survival of pathogens, and also environmental weather-related practice. So next slide, please. So our goal was survey the soil, so sampling the soil after the application of manure, and then that soil used for fresh produce, different types of produce. So what we test the soil cereals every month, and here on this diagram was before baseline, and after application of manure, that's represented by 0B. And then every month we sample the same soil and looking at different pathogens in soil. We saw for these farms, we saw a difference in type of manure they're using between fresh manure up to 12 months manure in the pile. The source was different with cattle, poultry, and horse, and as well the pathogen. The next slide, please. So here I'm just overview what we are able to detect in the soil, and this is grouping all the farms. And what we saw is this graph represents the proportion of positive samples of the soil across all farms, the 2 years that we identify in the soil by time. And here highlighted in yellow is after the manure application. So it doesn't matter what pathogen we test, if it was Shiga toxin, E. coli for this case, or Listeria X, we saw a peak after manure application and then a kind of a die-off as we go in time. Next slide, please. So for Listeria, the same peak after, but a much smoother die-off as we go over time after the manure application. So most of the plots were able to follow up to 180 days after the manure application. So next question is, what factors are affecting our ability to detect those pathogens in the soil? So from that diagram I showed before, so next slide, please. So besides testing the soil, we ask questions about management practice, and we account to different factors as manure-related factors, management, land use, agronomic practice, irrigation water, environmental factors, and soil, among others. But what is represented here in this slide is actually the factors that we identify and were associated with the presence of STEC and Listeria. And they were related to manure application, when the manure was applied, the presence or not of pathogens in manure, and how was applied the manure. Also the land use, as for example, field use, if the field was used for livestock or presence of animal feces in the field, and the water source. So from this, what we have to think about is what these factors we actually can use as a management practice to reduce the risk. So there's some factors as the weather or sampling day, the time, actually cannot do much about it, or the soil moisture. But another management agriculture practice we can learn from what are those risks, and then implement risk mitigations practice to reduce the risk. Next slide, please. So the final goal of this project was provide to the farmers a risk tool, a risk score and risk assessment tool. So based on their survey and their practice, we rank the farms in different risk score, and then they could see what are their risks related to the other farms. So the ultimate goal is actually recommendation of risk mitigation practice, and that's why we come up with this webinar series about some of those that Betsy and Donna will talk the next talk. So next slide. So finally, I just want to say that this has been a great teamwork, and the importance of this multidisciplinary research. So we initially start with a planning grant, working with the Organic Center, the Trade Association, the other universities, and we hear really the farmers and the industry involved with organic production to understand what are the needs, what are the practice in terms of manure and biological soil amendments, and what are the needs in terms of research. But our ultimate goal is actually going back to the farmers and having practical recommendations in terms of biological soil amendments. And I want to emphasize how important it is actually have this collaborative work it's on the farm and doing these long-term projects that are, the findings will be much more applicable than we're doing these on a research farm, on campus and so on. So next slide, please. So this is just an overview of the project. There's a lot of data, and but I want to just finish and acknowledge all my collaborators and the great team that has been working with for last years. And that's all. Thank you.
All right, thank you so much, Alda. And I'm sure that everyone has a lot of questions, but let's hold those to the end. And I'm going to pass it over to Donna. Go ahead.
Excellent. Thank you, Jessica. So I really appreciate the introduction that both Jessica and Alda gave. For this next part of the presentation, we're really going to take a step back and give a little bit of background into some of the requirements to the Food Safety Modernization Act Produce Safety Rule, the National Organic Program standards, and give you some research and data about how some of those numbers were developed. So in this next presentation, we're really going to talk about how soil amendments can be managed to help improve soil health. And a key part of this is improving soil health while considering food safety risk and trying to address those risks. So over the next 25 minutes or so, we are going to talk a little bit about how the use of soil amendments can improve soil health. And then we're going to talk through a couple of key definitions, looking at produce safety risks when using untreated biological soil amendments of animal origin. And you're going to see this term come up many times throughout this presentation. I might also call this BSAAO, use the acronym. And then we're going to address different practices to reduce risks, including the use of application intervals. And this is something that Jessica introduced during the beginning of the presentation. And then lastly, we're going to talk a little bit about some of those frequently asked questions about the use of biological soil amendments of animal origin, and then save some time for questions at the end. Next. Okay, so growers have a number of different options for improving soil health. And although they have a number of different options, research has shown that these 4 practices listed here really have the most impact on building soil health. So we talk a lot about cover cropping, crop rotation, modified tillage practices such as no-till, strip tillage, and then lastly, the application of soil amendments. And when you look at the research, each of these different practices provide unique benefits to building soil health. So for example, cover cropping is often used to improve the structure of the soil, reduce runoff and erosion. Crop rotation, which is sort of the subsequent planting of crops in the same location. Crop rotation is very helpful for adding nitrogen into the soil if legumes are used. It's also used for increasing biomass. Modified tillage practices have benefits to soil structure, in turn, which helps with water holding capacity in allowing water through irrigation or natural rainfall to infiltrate better into the actual soil so then crops can use it. And then we'll go into some of the benefits of soil amendments. But the key thing that I want to highlight here is that a lot of growers, especially organic growers, will use these options in combination. And the focus of this presentation is really going to be about this last category, application of soil amendments, because when we look at food safety risk, it's really this last category that impacts food safety the most through the introduction of raw manure or other types of soil amendments. Next. And I mentioned that I wanted to quickly set the stage with some definitions here. So when I talk about soil amendments, first of all, there are a number of different options for growers to use. And you'll hear me use a couple of the same examples over and over again, but I want to highlight that the types of soil amendments that are used on farms vary greatly by region, by the type of farm that people have. But looking at the definition of a soil amendment, we're defining it as any chemical, biological, or physical material added to the soil specifically to improve the condition of the soil. And this often comes about when we talk about soil health. And soil amendments are often also used to help improve plant growth, which in agriculture is one of the direct benefits of using soil amendments. Some of the examples from a broad category of soil amendments include chemical fertilizers, animal-based soil amendments. I heard one of the questions that was pre-submitted asked about mineral-based soil amendments, such as lime. That would also be considered a type of soil amendment here. And I wanted to highlight that cover crops, such as green manure, would also technically fall under this definition, because when cover cropping, oftentimes that cover crop is often tilled into the soil or rolled down, and it's used to increase the biomass of the soil. Next. But in this presentation here, we are really going to be narrowing down this definition of a soil amendment and specifically talking about biological soil amendments of animal origin. This is one of the categories of soil amendment that represents the most significant microbial risks, in addition to soil health benefits. So I really want to highlight here that soil amendments are an excellent way to help build soil health. However, it is important that we manage the risks. And BSAAOs, or biological soil amendments of animal origin, are really narrowed down to, as the name implies, those soil amendments that come from some animal origin. So some examples here are going to be raw manure, treated compost, bone meal, blood meal, fish emulsion is another one that I frequently hear about on farms. Next. And looking at how these specifically biological soil amendments of animal origin, or BSAAO, benefit soils very directly often these BSAAOs are used to increase organic matter to the soil. That's one of the very direct measurable benefits of adding soil amendments. However, indirectly, through the increase of organic matter, there are a number of different benefits that research has shown us from using soil amendments in the soil. So improved soil fertility. So this could be increased nutrient availability for plants to uptake, which can then increase yields, increase buffering capacity, improving the structure of the soil. And a lot of these factors come down to helping the soil hold onto water, which then can be used by crops to, again, increase plant yield. And then as well as reducing soil compaction. So a lot of these are directly related to improved structure of the soil, which then leads to improved plant growth and increased plant yield. And then I also want to mention improved microbial diversity. So this is something that we see directly from an increase in organic matter in the soil. And there is some research, which we'll talk about in later slides, that indicate that improved microbial diversity of the soil has led to a reduced pathogen persistence. And we will revisit this when we talk a little bit about pathogen die-off in raw manure application. Next. So I talked a little bit about different types of soil amendments, and we're going to introduce another category of soil amendment, which is treated versus untreated biological soil amendments of animal origin. And the reason I'm bringing this up here is that there are differences in risk that come about between using these two categories of soil amendments. When I say an untreated soil amendment, that is something like raw manure. It is a soil amendment that has not been through a treatment process, such as composting. And that's a validated process that is intended to kill off potential pathogens in that soil amendment. So untreated soil amendments, as Alda mentioned before, are going to be higher risk because they've not been treated. We often do see that there are human pathogens in raw manure. And the FSMA, the Food Safety Modernization Act Produce Safety Rule, this is a federal regulation that Jessica mentioned in the introduction. This is as I mentioned, it's a federal regulation by FDA, and it is intended to minimize risk from produce. So it's trying to minimize the number of food safety outbreaks that happened nationally. And in this regulation, they have an entire section that regulates the application of biological soil amendments of animal origin. And in the produce safety rule, they outline two different treatment processes. However, they allow for other validated risk-reducing processes to be used. And this is really an introduction into this discussion of treated versus untreated soil amendments. The next webinar that Organic Center is hosting on July 23rd, we actually have a whole webinar discussing treatment processes. So if this is something that interests you, I encourage you guys to tune in. But the key here is that in untreated soil amendments, or if that soil amendment has been recontaminated with potential pathogens, then it is considered untreated, and there are specific risk reduction measures that are to be taken. Okay, so in the next couple of slides, we are trying to get you guys to think through some of the categories of soil amendments that growers use on the farm. So I'm going to encourage you guys to participate. We are going to pull up a poll in a moment. But next, if you look at this slide, this is a photo of application of chemical soil amendments. So if you go, I'm not sure if Libby hit next, but the question here is chemical soil amendments going to be a biological soil amendment of animal origin, yes or no? So Libby, you can pull up that poll. And I encourage you guys, we're going to do this quickly, so I'm going to give you guys about 15 seconds to respond. Is chemical soil amendments considered a biological soil amendment of animal origin? Okay, Libby, you can go ahead and close that and share the results. Excellent. So 88% of you said no, chemical soil amendments are not considered a biological soil amendment of animal origin, and you would be correct. Synthetic, mineral-based chemical soil amendments such as lime, they are not considered a BSAAO because they are not from animal origin. They are synthetic or from some kind of mineral. And then usually these types of soil amendments are going to not be very risky because they usually do not support the growth or carry human pathogens. Next. I have a couple more examples for us to run through. Okay, so this next example, next is going to be considered as pre-consumer vegetative waste. So this is a pretty lengthy term. The key here is vegetative waste before it gets to the consumer. So this might be vegetable scraps. These might be outdated fruits or vegetables. If a grower is using pre-consumer vegetative waste, it might be old produce that they're bringing back from the farmer's market. But the key here, the question here is this considered a biological soil amendment of animal origin? Yes or no? And you can watch the poll, Libby. I'll give you guys about 15 seconds to respond.
Sorry, Donna, it's not going to let me run the BSAAO question again.
Oh, okay, no problem.
Folks can chat it in if we want to like see some of the responses. Sorry about that.
Sure, no problem. You guys are welcome to put your answer in the chat box if you think this is a biological soil amendment of animal origin, but I'm just going to walk through the discussion. So this is not considered a BSAAO, again, because it's not considered animal origin. And the reason I'm walking through these questions in these categories is in the FSMA produce safety rule, that federal regulation, it's really narrowing down these soil amendments to biological soil amendments of animal origin. So it only regulates and has requirements for those specific BSAAOs. Next. And I should say that pre-consumer vegetative waste, as long as it's not table waste, which is post-consumer, it is going to be considered relatively low risk in terms of human pathogens. Okay, so the next example that we have is bone meal and blood meal. And these are two questions or two categories that I often get questions about. So the first question is going to be, is this considered a biological soil amendment of animal origin? Yes or no? And the key here is animal origin. So I'll go ahead and say that bone meal and blood meal both are considered BSAAO because they come from an animal source. They're biological soil amendments that are coming from an animal source. Next. Okay, so I'm going to throw in an additional two questions here. The first one is this considered a treated soil amendment? Yes or no? And I'll go ahead and walk through this. Oh, here we go. Thank you, Livy. So using your gut, do you think this is considered a treated soil amendment? And Libby, you can close and launch the results after about 15 seconds. Excellent. So most people answered yes. Thank you, Libby. And I would agree with you that most likely both of these are considered a treated soil amendment because these two products often go through a validated heat treatment process. And we're going to talk more about this next week in composting and other treatment processes. Okay, next. As the slide is getting pulled up, the next example that we have to discuss, and the last example, are aged and stacked manure. Excellent. Okay, so you can go through to the next slide, Libby. Okay, and as that's getting pulled up, when we say aged and stacked manure, Growers often ask me, they say, hey, you know, I have a whole pile of manure out back. It might be next to the barn from cleaning out the horse stalls or the feedlot. Is this considered a biological soil amendment of animal origin? And the answer is going to be yes, because it is directly from an animal. One of my favorite terms I came across recently was voided from an animal. That was in a research study. And I'm going to ask you, is this considered a treated soil amendment? And the answer is going to be no, because it has not been through a validated treatment process, such as composting, where temperatures are taken. We're really monitoring the number of times it's been turned. But we are going to get into that in a couple of minutes. And then lastly, do you think this is considered a high, medium, or low pathogen risk? So looking at age-stacked manure, it is a biological soil amendment of animal origin. It is not considered treated. And Libby, you can launch that last poll. Okay, so taking about 10 seconds here, do you think this is going to be, I'll ask, do you think this is going to be risky or not? So yes or no in terms of risk here. Okay, you can share the results. Okay, excellent. So a number of you said, yes, you think it's going to be generally risky, especially compared to some of the other types of soil amendments that we talked about. Excellent. Next. Okay, and I appreciate you walking through that activity with me, because when we work with growers to adopt practices to minimize risk on the farms, these are exactly the types of questions that we ask growers to do. So we ask them to walk through what is the general risk of their practices. And moving forward into the rest of the presentation, we're really going to be sharing with you a number of these recommendations for how to minimize risk on the farm, especially when using raw manure and other types of untreated soil amendments. Okay, so as the slide is advancing, you can go to the next slide, Libby. Alda mentioned that part of the OREI project was to provide a national survey to organic growers a few years ago. And one of the questions that was asked was, what is the type of soil amendment that is being used on the farm? And 58% of growers that were surveyed used raw manure. You can go to the previous slide. 58% of growers surveyed used raw manure on the farms, and 74% did not treat prior to applying fields. There's a number of different reasons that growers may use manure in favor of compost. Even though compost is treated, it's generally lower risk, it does come at a cost. It's more expensive. It can be difficult to transport, especially if manure is already on the farm. And there is a lot of work involved in composting and treating a soil amendment. So there are a number of reasons that growers would use raw manure directly on produce fields. And in terms of the reasons for using soil amendments containing animal manure, soil health, nutrient management, tilth, cost, these were all big factors in that decision. And I also want to highlight that organic growers are really limited to using biologically based fertilizers such as soil amendments and cover crops. So organic growers have some limitations in the types of soil amendments that they can use, which is one of the reasons we see more organic growers using raw manure than non-organic growers or conventional growers. Next. Okay, so as Alda introduced earlier, there are some risks when it comes to using raw manure. We see that certain animals tend to be reservoirs for certain pathogens. So for example, sheep and cattle, other ruminants, we see will have E. coli 0157H7 in their manure. Whereas poultry, such as chickens, will have Campylobacter and Salmonella in their manure. So we tend to see different pathogens associated with different types of manures. However, there are some ways that we can try to minimize this risk. And I already mentioned treatment. We can recommend prioritizing the use with non-produce crops, preventing cross-contamination through good sanitation practices. So this really comes down to monitoring tool usage and thinking about how tools are used to move manure and what other practices they might be used for. And then lastly, where I'm really going to focus in the next couple of slides is maximizing application to harvest intervals. Next. And one of the ways we talk about these harvest intervals are through the National Organic Program 90-120-day rule. But first, one of the main reasons that an application interval is recommended is because research shows us that pathogens often do die off over time when raw manure is applied to the field or to the soil. And you can see this figure here shows a nice die-off curve. So on the x-axis, we have the number of days. So over time, the levels of E. coli 0157H7 gradually decrease. And this is due to a number of different factors, but one of the big factors is environmental organisms can outcompete human pathogens. So human pathogens such as Listeria monocytogenes, E. coli 0157H7, they do not survive very well outside in the environment. So we see that soil-borne organisms can often outcompete them, and then they do lead to that die-off. And some of the related factors include limited availability of nutrients. It's much cozier in human intestines than it is outside where there's UV light. The soil might dry out and desiccate. But I wanted to highlight here that the research Alda discussed and introduced is really going to continue to expand our understanding of die-off. Next. Okay. So Jessica, in the introduction, talked a little bit about the National Organic Program. And this program established intervals for application and incorporation of untreated soil amendments to produce fields. And specifically, it requires a 90-day application to harvest window. So waiting 90 days between applying that soil amendment and harvesting the crop if the crop does not contact the soil, or 120 days if that crop does come in contact with the soil. And this is one of the questions we often get is, can we assume after 120 days that we're good to go, everything's safe? And I wanted to highlight in background that this 90-120-day rule was not necessarily in place for food safety. So there's a quote in the preamble of the Organic Foods Production Act that mentions that the NOP is for marketing, not food safety purposes. However, that said, this 90-120-day rule is often cited as a way to safely reduce risk when using raw manure. Data is out there to indicate that some pathogens persist in soil beyond that time frame, and Alda showed one of those in her figures. But again, there is a lot more research being done to try to come up with what number might be more protective than 90 or 120 days. Next. Okay, so this is going to get into a little bit of discussion about the FSMA produce safety rule. Jessica mentioned that the Organic Center wrote in comments when this produce safety rule was originally proposed, and one of the outcomes was that FDA has decided not to publish an application interval yet. They are pursuing additional research, and we may not know what that research looks like until 2026. So it is a number of years out there, but I do want to highlight here that in the produce safety rule guidance document, FDA believes that adhering to a 90 or 120-day application interval is a prudent step toward minimizing contamination. So in the meantime, we can work with 90 and 120 days because we do know that some die-off often does occur in that time frame. Next. And in this next slide about other factors that impact pathogen die-off, I really just want to highlight here that the relationship between pathogens dying off in the soil is very complex. There are a number of different factors that impact the number of, that die-off, that length of time. Things like soil moisture. Some of these things are factors that growers can control, such as application rate, how is it being managed, but other things are really out of their control, like temperature, seasonality, even sometimes soil moisture. So this is one place that data is still being looked for. Next. Now, I wanted to quickly highlight another frequently asked question that I receive, which is about aged manure and minimally managed compost. And this goes to one of the activity questions or the poll questions I asked earlier. In the produce safety rule, aged manure and minimally managed compost, which is usually compost that is, it's sat outside, it's not treated, it's not turned, they don't measure the temperature. This is considered an untreated soil amendment because it has not gone through a standardized treatment process. There is some research to show that E. coli 0157H7 and Listeria species in bovine manure, specifically from feedlots, is reduced over time. So after aging, after sitting this pile outside, there is some reduction in pathogens. However, it's variable. It's really difficult to say, okay, after X number of days, you're good to go. And the reason is that pathogens are still present in some samples. And I have a couple of arrows here in this image. One of the places that they often found pathogens still present was in the outskirt samples. So if you look at the edge of the pile or the pile toward the bottom, closer to the concrete, those often had pathogens still persist. And they think it was due to differences in temperature buildup. Often the top and the middle of the pile will build up temperature more quickly. But it's highly variable, which is one of the reasons that these types of soil amendments are considered untreated. Next. Okay, so the key here that I wanted to highlight on this slide was to consider your on-farm practices. So again, I want to highlight that there is not data for every type of soil amendment or practice to fully understand your risks. So it's really up to you as growers to think about your risks, some of the practices that you're doing on the farm, and then try to think about the factors that you can control. So what type of soil amendment are you using? How much are you applying? How are you storing it? And things like that. Next. Okay, so survey data has shown us that although raw manure is one of the most commonly used soil amendments for organic farms, rotational grazing was one of those that often came up as an additional practice. And just a very quick introduction to rotational grazing, this is often when animals, livestock, are moved from a pasture to a produce area. And it's often to consume some of that crop residue. And it also, one of the side benefits is depositing manure into the soil. However, rotational grazing can be a risk, and it's something that we need to consider. Next. Okay, so I'm going to quickly go through these next couple of slides, but I just want to highlight from a production standpoint. Growers are often used who do use rotational grazing. They're often encouraged to follow that 90, 120 day rule. This is considered pretty protective because in rotational grazing, there is less manure being deposited. So there's less poop being deposited into the soil. And so the NOP 90, 120 day rule is often recommended. The produce safety rule suggests that rotational grazing could be considered as an intrusion event. So it could be considered the same as if a bunch of deer or sheep or something came into your field. However, a lot of growers find it more easier to plan around that 90, 120 day rule when they're planning out their rotations. I just wanted to mention that. And you can skip through 2 slides. And I will mention that research shows that, and you guys do have access to these slides, research shows that there is a die-off over time in rotational grazing, just as there is in pathogen die-off. And the research does really support using that 90, 120 day rule for rotational grazing. So the last couple of points that I wanted to make were storing and handling soil amendments. But really here, the consideration is directing the flow of traffic around storage areas, risks of cross-contamination, and think about how those soil amendments are being stored so it doesn't run off into production areas. Next. And the last thing I want to highlight in this presentation are some of the documentation requirements and recommendations. So in the National Organic Program, there are requirements that organic growers keep records of soil amendment use. This includes type and source of soil amendment, application rates. All of these are factors that research shows goes into die-off of manure. But then probably most importantly, the interval between application and crop so that organic growers can prove that they're following the 90, 120 day rule. And you can skip forward 2 slides. So with that, I really wanted to thank our collaborators. This is outreach that is part of the OREI project. And the next slide. With that, I'm going to leave off. And I do want to ask for your input. So one of the links that you will receive after this presentation is a Qualtrics survey. I would appreciate if you guys could fill that out because this presentation is actually being adapted into a public module so we'll refine the content and it will help us develop a better extension resource. So please do take about 5 minutes and input your comments in the Qualtrics survey. One randomly selected survey respondent will win a basket of goodies from the Cornell Dairy Store. Okay, and I'm going to hand it back over to Jessica.
Great, and I'm actually going to have everybody jump on to join me. So Alda and Donna, you guys have heard talk. We also have Betsy. We do not have a lot of time for questions, and we have a ton of questions, so I'm just going to jump right in. So, okay, one of the questions is looking at pathogen risk from the other direction, what does the data say regarding foodborne illnesses linked to the use of BSAAO treatments, other application and application intervals? So kind of rather than just looking at pathogen presence, how about connecting that directly to foodborne illness and pathogens actually on the produce? Alda, you might be muted.
Oh, sorry about that. I didn't mention in my presentation, but we did test produce as well, about 500 samples, and we only detect 2 samples with listeria. So I have to say the contamination from the soil to the produce is quite rare. And we only found it in 2 samples, and that's identical in other studies done in conventional, very rare you find pathogens in a produce. Maybe Betsy or Donna want to talk about the risk assessment that FDA is conducting, so that will answer directly the relationship to illness.
What? I'll let Donna do that. I was going to say too that in the research that you read, it is rare that it transfers to the plant when they look for it. And when we see produce-related foodborne illness outbreak data, usually it's not a smoking gun. They usually include it amongst the things that could have resulted in the illness. In the same way we see could have been water, could have been soil amendments. Certainly, if they look at fields where they have used soil amendments, biological soil amendments of animal origin that are untreated, we know there are risks there. And if the pathogen that shows up in the outbreak is related to that type of amendment, it certainly gets listed. But I, off the top of my head, cannot point to a specific outbreak where there was a definitive link. Not that I'm not saying I'm the big brain in the room, but off the top of my head, I can't pull one out. Donna.
Yep, I was just going to say exactly what you did, that when we see outbreak, it's one of those things that it could have been linked to this because it was adjacent land use, or it was some other type of manure that may have been come over through runoff or wind, but it's usually not the smoking gun. Absolutely.
Yeah, and we do know, like, there is good data that shows that pathogens can move in the wind. That's a great point, Donna. So these things that Donna mentioned in her presentation about paying attention to location of compost piles and stuff like that is really important in terms of risk to the plant. And again, normally when people get sick, it's I don't say it ever happens, but it's rare that it's the whole crop. It's usually a portion of the crop that gets contaminated, and then that contaminated makes a subset of the people that eat it sick. And so that's the real issue that we're contending with, is if it was easy to figure out where the contamination is coming from, we would have controlled it by now.
All right, so another question is, the pathogen graphs that you showed emphasized an end goal of 0. Is there consideration on natural baseline pathogen levels on agricultural soils that have never had application of biological soil amendments of animal origin?
Alda, do you want to talk about that?
Well, I think, yeah, I can talk about that. So I believe they are maybe referring to the difference from your graph to my graph. So I believe your graph was, inoculation study, while what the graphs I present is no 0 actually. So we did test on baseline, and we didn't baseline, meaning before adding manure to the soil, and we found in certain farms pathogens. But then when you compare, day 13, 19, and so on, we saw most of the pathogens that was lower. We found less than the baseline. So basically, risk 0 is not the goal. I will not find that, but we see that nice die-off and curve after application, after tilling the soil. I have to refer that in this study, we didn't link the same strain that we found in the soil to the manure. So we did more as overall assessment. So it's not pinpoint to the manure. So the findings I present was risk factors, meaning is associated with the presence. Can you tell in this study is from the manure or the wildlife? Maybe not. But in terms of epidemiological data analysis, we can see that association. Do you want to add anything, Donna?
Yep.
And the graph I present is not the concentration in the soil, as you might see other graphs, is actually the proportion of positive samples over all the samples. So we see that proportion decreasing over time.
All right, and we only have 2 minutes left, so I think I'm going to have to hand it back to Libby. Thanks everyone so much for joining us. I'm sorry we didn't get all the questions, but there's a ton of information.
Can I continue typing answers into the chat box? Okay.
Yeah, absolutely. Thanks, Betsy, for doing that. And thanks to all of you for such a fantastic presentation today, and to all of you in attendance. As I'm sending again through the chat box, just a reminder as well to register for next week's webinar if you haven't yet, and if not, make sure it's on your calendar. We want to see you there for sure. So thanks to all of you. We had over 120 people that were here today engaged, and it was such a fantastic presentation. Thanks to Alda, to Betsy, and to Donna for such a fantastic presentation, and for Jessica for helping to pull everything together. We appreciate all your patience with some of the technology issues today. On behalf of the staff and the members of the Organic Trade Association and the Organic Center, We really appreciate your time and commitment to organic and to the work for today's webinar. On behalf of the Organic Trade Association and the Organic Center, we hope to have you join us for future educational opportunities. We hope to see you next Friday at noon, 9 a.m. Pacific, and please do have a wonderful weekend. Thanks so much.
Thank you.